Hi everyone, my name is Elder Brian Angelo S. Ledesma from BS ECE 3B. And this is my presentation on ECE 23 Performance Task number 10. So in this presentation, we will talk about ATM or Asynchronous Transfer Mode. So Asynchronous Transfer Mode or ATM is a switching technique used by telecommunication networks that uses asynchronous time deviation multiplexing to encode data into small or fixed size cells. So, ATM is different from Ethernet or Internet, which use a variable packet sizes for data or frames. But for ATM, is the core protocol used over the synchronous optical network or SONET and backbone of the Integrated Digital Services Network or ISDN. ATM is a telecommunication standards defined by ANSI and ITU-T or formerly called as CCITT. For digital transmission of multiple types of traffic, including telephony or voice, data and video signals in one network without the use of separate overlay network. So the origin is ATM was developed to meet the needs of the Broadband Integrated Services Digital Network, as defined in the late 1980s. So the origin year of the ATM was on the year of 1980s and designed to integrate telecommunication network. So the function of ATM is that ATM provides functionality that uses features of circuit switching and packet switching networks. It uses asynchronous time deviation multiplexing. In the OSI reference model detailing clear, the basic transfer units are generally called frames. In ATM, these frames are of a fixed or 53 octets or bytes length and specifically called cells. This differs from approaches such as IP or Ethernet that use variable size packet or frames. So, another function is that the ATM reference model approximately maps to the three lowest layer of the OSI model, which is physical layer, data link, and network layer. ATM is a core protocol used in the SONET or SDH backbone of the Public Switch Telephone Network or PSTN and in the Integrated Services Digital Network or ISDN, but has largely been superseded in favor of the next generation network based on the Internet Protocol or IP technology. While the wireless and the mobile ATM never established a significant foothold. So, these two photos are examples of ATM that developed by IBM and Marconi. So first is the IBM TurboWays ATM 155 PCI network interface card. And next is the Marconi Fornell ATM PCI network interface card. So the protocol architecture of ATM is that at the time of the design of ATM, 155 mbits per second synchronous hierarchy or SDH with 135 mbits payload was considered as a fast optical network link as its time. And mini Chronus digital hierarchy or PDH link in the digital network were considerably slower, ranging from 1.544 to 45 mbits per second in the US and 2 to 34 mbits per second in Europe. At 155 mbits per second, a typical full length is 1500 byte or 12,000 bit data packet. Sufficient to contain a maximum size IP packet for internet would take 77.42 microseconds to transmit, which is lower than the present of this present time. And a lower speed link such as 1.544 mbits per second or T1 line, the same packet would take up to 7.8 milliseconds, which is much slower for its time and in the present now. A queuing delay induced by several such data packets might exceed the figure of 7.8 milliseconds several time over. In addition to any packet generation delay and the shorter speech packet, this was considered unacceptable for speech traffic, which needs to have low jitter in the data streams being fed into the codec if it is to produce a good quality sound. A packet voice can produce this low jitter in a number of ways. First, such as using a playback buffer between the network and the codec. One large enough to tie the codec over almost all the jitter in the data. And this allows smoothing out the jitter. But the delay introduced by passage through the buffer require echo cancellers even in local networks. So this was considered too expensive at the time. Also, it increased the delay across the channel and made conversation difficult over high delay channel. So at the time, the transmission of ATM was so complex. So using a system that inherently provides low jitter and minimal overlay delay to traffic that needs it, and operate on a one-on-one user basis. For example, dedicated pipe. So here's the ATM or asynchronous transfer mode network, which is it uses multiplexing. So on the first data is the voice, and the second is data packets, and for third and for the last is the image. So here it shows the wasted bandwidth present in the TDM, which is lot of wasted bandwidth. But in ATM, they are less wasted bandwidth but more on transmission, which sending data, which is more accurate. Then the predefined speed that ATM technology offers on the optical fiber is 155.520 Mbps or 622.080 Mbps, which we call it the default bitrate, but speeds in ATM can be up to 10 gigabit per second, which is much more higher. And in this regard, this transmission technology is considered as the fastest broadband network services. Apart from the other technologies like synchronous optical network or SONET, as well as from other technologies, ATM is the key component of ISDN broadband or BISDN network. So, the ATM mechanisms is dedicated communication that divide digital data into small section of 53 bytes and sends it to the physical media into small cells or cells. And sometimes, in some cases, the type of data transfer mechanism is also referred to as cell switching. So, each cell being processed separately before it is split up and transferred to the media, and this processing is done without communication and the need for other cells, asynchronously and asynchronously. The cell structure used in the ATM causes the routers not to process the various sizes of the packets. Hence, the processing speed increases and the delay in the path decreases. That's why experts believe that ATM is a solution to increase the bandwidth of the internet. So, the cell structure of the ATM. An ATM cell consists of a 5-bit header and 48-byte payload. So ATM defines two different cell format: user, which is user network interface or UNI, and network to network interface or NNI. Most ATM links use UNI cell format. So this diagram shows for the UNI ATM cell, which consists of JFC, BPI, BCI, and HEC, PT, and CLP. So under is the payload padding if necessary for 48 bits. For second diagram is the diagram of an NNI ATM cell, where it consists of BPI, BCI, HEC, PT, CLF, CLP, and HEC. Same as on the NNI UNI ATM cell. So GFC means the generic flow control, or GFC. Field is a 4-bit field that was originally added to support the connection of ATM network to shared access network such as a distributed quad dual bus or DQDB ring. The GBC field was designed to give the user network interface or UNI 4 bits in which to negotiate multiplexing and flow control among the cell of various ATM connections. However, the use of exact values of the GPC field have not been standardized, and the field is always set to 0. So, BPR or virtual path identifier use 8 bits UNI and 12 bits in NNI. For BCI or virtual channel identifier, which uses 16 bits, and PT or payload type is 3 bits. So the PT have 3 categories, which is PT payload type bit 3 or MS bit, network management cell if 0, and user data cell, and the following apply. So payload type bit 2, explicit forward congestion in the indication or AFCI. 1 equals to network congestion experience. So first is the payload type bit 1 IS bit ATM user to user or AAU bit used by AAL5 to indicate packet boundaries. So CLF, cell lossy parity, uses 1 bit, and the HEC or header error control uses 8 bit CRC. Polynomial equals to x8 plus x squared x2 plus x plus 1. So here is the asynchronous transfer mode network, which is the LAN switch, workstation, and the router goes to ATM switch and goes to the cloud network, and go back to the ATM switch and go to router and workstation. So services types of ATM. ATM support different types of services via ALS or standard ALS, include ALS1, ALS2, and ALS5. And they're rarely used on ALS3 and ALS4. And ALS1 is used for constant bit rate or CBR. CBR or constant bit rate. Services and circuit emulation. Circulation is also maintained at AL1, AL2 through AL4. Are used for variable bitrate or VBR services, and AL5 for data. ATM can build virtual circuits and virtual paths either statistically or dynamically. Static circuits or permanent virtual circuit or PVCs, or paths, permanent virtual paths or PVPs require that the circuit is composed of a series of segments, one for each pair of interfaces through which it passes. PVPs and PVCs, through conceptually simple, require significant effort in large networks. They also do not support the rerouting of service in the event of failure. Dynamically build PVPs or soft PVPs or SPVPs and PVCs soft PVCs or SPVCs in contrast are built by specifying the characteristics of the circuit or the service contract and the two endpoints. So, key concepts. Another key ATM concept involves the traffic contract. When an ATM circuit is set up, each switch on the circuit is informed of the traffic class of the connection. So, ATM traffic contracts form parts of mechanism by which quality of service or QoS is ensured. There are four basic types and several variants which each have set of parameters describing the connection. So, CVR or constant bitrate, a pixel rate or PCR is specified which is constant. So, VBR or variable bitrate, an average or sustainable cell rate or SCR is specified, which can peak at a certain level, a PCR or for maximum interval before being problematic. So, AVR or available bitrate, a minimum guaranteed rate is specified. UBR or unspecified bitrate, traffic is allocated to all remaining transmission capacity. So for VBR has real-time and non-real-time variants. And served for bursty traffic. Non-real-time is sometimes abbreviated to VBR or -NRT. Most traffic classes also introduce the concepts of cell delay variation tolerance or CDVT, which defines the clumping of cells in time. So, the deployment of ATM became popular with telephone companies and many computer makers in the 1990s. However, even by the end of the decade, the better price or performance of the Internet Protocol-based products was competing with ATM technology for integrating real-time and bursty network traffic. So, companies such as Four System focus on ATM products, while other large vendors such as Cisco Systems provided ATM as an option. After the burst of the dot-com bubble, some still predicted that ATM is going to dominate. However, in 2005, the ATM Forum, which had been the trade organization promoting the technology, merged with a group promoting other technologies and eventually became the Broadband Forum. So that's the end of my presentation.